Hello and welcome to week 5 of Computer Science 12. This week we're going to be learning about if-else statements. We can finally test to see if things are true and false. This is called branching. It makes it so that we can tell the code where we want it to go depending on a condition. So this is branching. And next time we're going to learn about looping. So this controls the flow of the computer code and the way it goes, and it allows you to go off in different directions depending on the answer to a question. So we call that question the condition, and the way that we have an if statement in Java is we use the keyword if. In parentheses, we put a condition, and then we have a statement. Now you might also have if condition one statement and otherwise another statement. So if a certain condition is true, you're going to do one thing, and otherwise you're going to do another thing. And you'll only do either the one or the other. You can have multiple statements inside of your if or else section, but if you do, you need to make sure you put brackets around them. So I can have if condition, multiple statements, else, multiple statements, make sure the brackets are there. I can also do an else if, so I can kind of staircase my if conditions. I can have if I do one thing, else if another condition, I do something else, and finally else, I do something else. And you only go into one of these branches. Once the code goes into one of these conditions, then when it gets to the end of the brackets, it jumps out. So you have to be very careful when you are coming up with your conditions that you make them so that the code knows exactly where to go. I'll have to give you an example of a bad condition, bad if statement later. Okay, so the condition part, when I had if condition, that has to be a Boolean expression or a function call. And Boolean expression or function call means it needs to evaluate to true or false. So whatever you put into the condition needs to evaluate to true or false. So we've seen some functions that return true or false. Some of the string functions return true or false, and there are other ones. But if we want to just check maybe if some numbers, compare values, in order to do that, we have some operators that we can use. So we have greater than, so A greater than B, less than, this is greater than or equal to, there is no space between the greater than and the equal, less than and equal to. Equivalency is two equal signs, because we know that if you put a single equal sign, that means assignment. We're assigning a value. So we use two equal signs to show equivalency. And then we have not equal. An exclamation point is a not. So not equal, we can test for that. We also have some other Boolean operators. We have Boolean and, Boolean or, and Boolean not. And hopefully you learned in CS10 that doing a Boolean and, if they're both true, if both sides of the expression are true, then you will result in a true. If one is false, then the result will be false. With an or, if either or the other, if one or the other is true, or both, then you have true. But if they're both false, you have false. And then not, it's going to turn a true into a false. So hopefully that's something you already understand. If you don't, let me know. I can explain it in more detail. So here's an expression, A less than B and B less than C. So this would have to be true and this would have to be true in order for the whole thing to be true. Here are some examples. I have an example here. If x is less than 10, then increment x by 1, else decrement x by 1. So suppose you come in here and x has a value of 3. Okay, is 3 less than 10? Yes. So we're going to increment x by 1, so x will become 4. If we come into here and x has a value of 12, that's not less than 10, it's going to skip to the else part, and it's going to decrement x by 1, so x will become 11. Hopefully that makes sense to you. Here's another example. It's checking if cost is less than 10, then we're going to set shipping to cost times 3%. Else, if cost is less than or equal to 10 and cost is greater than or equal to 10 and cost is less than 20, so now it's between 10 and 20, then we'll set a different shipping. Else, if cost is greater than 20 but less than 50, then we'll have a different shipping, and otherwise shipping will be free. Okay, so notice that the values I had to make sure, so this is less than, so this had to be greater than or equal. Okay, this is less than, this probably should have been greater than or equal. Greater than or equal. This is less than, so as long as it's less than 50, then we'll still have a shipping cost, and otherwise once it hits 50, it goes over. Suppose I had done something like I had accidentally said here if cost is greater than 10, and suppose cost is 50. Okay, cost is 50, and I come in here, it's going to hit the first one, which is cost is greater than 10, and automatically go to the shipping cost times 0.3, and it's not going to do what we wanted the code to do, which was skip all the way down to the bottom. So you have to be careful of your conditions, that they are working the way you want them to work. And it's always good to write things out on a piece of paper and test them with different numbers. So if I was going to test this the original way, suppose my cost is 35. Okay, so it's going to come here. Is cost less than 10? 35 is not less than 10, so we're going to skip to here. Else, if cost is greater than or equal to 10 or less than 20, cost less than 20, and notice you have to use the entire expression both times. Okay? We cannot do something like cost greater than 10, less than 20. That is not okay. Okay? We have to have it in two separate expressions that evaluate to true or false. So it's 35, so it is greater than or equal to 10, but it's not less than 20, so we're going to go to the next part. Now, if cost is greater than or equal to 20 and less than 50, this is true. It's 35. It fits in here, so this is the assignment that we're going to have for the shipping. Cost times 0.1. Okay, here's one last example. I have here a string selection, and I set that to an input. Do you want to calculate area or circumference? And I want the person to type in area or circumference, and that's what selection is now going to have. So now I'm going to use the string equals function here. So I have if selection dot equals area. So that means that the value of selection is equivalent to the string area. It's in double quotes here. Then I'm going to set the area to pi times the radius, pi r squared, and I'm going to print the area of the circle is. And notice that's in brackets because there are multiple statements within that if. If the selection is not equal to area, then I'm going to check to see if the selection is equal to circumference. And if so, I'm going to do these other calculations here and print out the circumference. And if for some reason they type in something that isn't area or circumference, I want to catch that. So I'm going to have another else here, and I'm going to just let them know that they've made an invalid selection. So it's always good to maybe have, this is a good way to catch errors if you're looking for certain input. Okay, but only one of these branches is going to be executed. And as soon as it is executed, we jump, the code, a flow of control jumps out of the if-else and moves on. Okay, now let's look at the examples in all the reading that I gave you. You were supposed to read about if-else. So here are a bunch of examples, and we're going to go through them. Here we have integer age equals CT input, enter your age. So someone would enter their age. If age is greater than 17, you print you're an adult. Otherwise, you print you are a child. So if the person enters 25, it's going to come here, age is greater than 17, it'll print you are an adult. If they enter 10, age is not greater than 17, it'll skip down to the else and print you are a child. Here's another example. You don't have to have the else part. You can just say enter your age. If they enter an age that's less than 0, then you can say this is an invalid age. You can also do more than one statement here inside of each conditional part. So if the age is greater than 15, you can have 2 print lines here. Otherwise, you can have 2 print lines, and then here we're telling them be careful. That's going to be printed regardless of what they type in. Always prints. There's a list of all of the conditional operators here that I already went through. Okay, here is an example. We have a Boolean variable called makeCircle, and we use an input yes, no. Remember that passes back a true or false. So you say, would you like to make a circle? If they say yes, that's true, and we create a circle. And if they say no or regardless, we say done at the end. Here's another example where they're asking for the height and weight, and we're testing here if inches is greater than 72 and pounds is less than 170. So both of those have to be true in order for it to print you are tall and thin. If one is not true, then this will not print. Notice I would probably put these in parentheses just to make it more clear that inches greater than 72, pounds less than 170. However, it's going to do the greater than and less than first, and then it'll do the and order of operations. So the extra parentheses are not necessary. But be careful when you are putting in compound conditions, make sure of the order of operations. And if you have a question, then make sure to put parentheses. Here's one with an or. You input a number from 1 to 10. If the number is less than 1 or the number is greater than 10, then we're going to say the number is out of range. So it has to be if one of these is false, then that's okay. If one of them is, either one of them has to be true in order for the number to be in range. Here's another example, entering height and weight into two variables, inches and pounds. So now we can say if they're either tall and thin or short and fat, then we don't have any clothes. So now we're testing if inches is greater than 72 and pounds is less than 170. That was the tall and thin. And here's the short and fat. I didn't write these examples, so I'm sorry. Hopefully no one is offended by this. I didn't write them, but they will not have any clothes to fit you, unfortunately. Okay, here's another one if you want to play again. So we're doing an input yes, no, and if so, you can do a CT restart, which starts your whole program over again. Here's an example of nested if-else statements. So you can actually put an if statement inside of another if statement. So here they're entering an age. If the age is less than 18, then we can print you're a child. But here, is your parent with you? So we have another if inside of here. If they say, you two must sit together, so it's asking if your parent is with you, then you need to sit together. And if your parent is not with you, then you cannot go on the ride. Try a different ride. Okay, and notice that here we didn't need brackets because there's only a single statement, but here we needed brackets because there are two statements. Notice also that this if, else, and the print line are all inside of the if part of the age less than 18, and the brackets keep that all together. Then the else just has this part. So if they are greater than 18, they're an adult and they can go on the ride. So brackets really make a difference. Nested if is fine. Just, be careful with your brackets and what you're testing and all of that. Here's the example of multiple if-else. So you have if age less than 18, you're a child. If age is greater than or equal to 18 and age is less than 65, you're an adult. If your age is greater or equal to 65, you're a senior. So this is, instead of what they have is 3 if statements, but really this could be if-else statements. So if age is less than 18, you're a child, else, you can put all this together, but you don't have to do that. This is the way that would be preferable. If age is less than 18, print you're a child, else if age is less than 65, print you're an adult, else print you're a senior. So you have the if, else, only one branch will be executed. Here's an example with some animation. Okay, we have a game object called a dot. In start, we initialize that object. So notice that this is a variable that can be used anywhere in the code. So it's a class level variable. So we're able to access it both in start and in update. So in start, we create a circle at 2050 of size 10, and that is now attached to the variable dot. So now we can check to see, now remember update runs 60 times a second. So if dot of x, so if the x is less than 50, we can say the dot is on the left. Else, we say the dot is on the right. So if we started moving the dot, say, then this would keep on printing. The dot is on the left, the dot is on the left, until it got to 50, and then it would start saying the dot is on the right. Now this dot isn't moving. We'd have to set the x speed or change the x, and then we could have it move. So what we could do here is dot x plus plus, we can increment. It will keep moving to the right. If we decrement dot, it moves to the left. So we can control which direction the dot is moving if we modify the x, or we can set the x speed and that will keep it moving each time. Okay, button. Here's another one where we have a button. We're going to make the button a circle, and we can test to see if somebody clicked, if you clicked on the button. So if your mouse clicks the button, it knows that. This comes back as true, and it'll print you press the button. Okay, here's another example. Here, this is an example of moving a dot a bit to the right each frame, but restart it on the left if it goes off the screen to the right. So this is a very good example. We have dot again, we make it into a circle. We're going to increment the dot. So it's going to go by half a pixel. It's going to start moving to the right. So if dot of x is greater than 100, that means it's gone off the screen. So we're going to set it back to 0. So it's going to move over. Once it gets off the screen, it's going to come back to 0. So it's going to continue to do that through the whole program, as long as the program is running. Then you can see if the user clicked. Okay, now this is just the users clicking their mouse. So if the user clicks their mouse, then we can say, well, did the user click on the dot? So now if the user just is clicking their mouse, we don't have to, what we could have done is just checked if the dot has been clicked. And we can say you got the dot, otherwise you missed the dot. You didn't really need to do this outside if, but this is a good example of nesting an if statement. Okay, so hopefully I'm not going too fast through this and you can follow what's happening. Okay. Okay, so here we have an example of comparing two objects, okay, and assigning two objects. If I have two objects that are assigned to each other, it's not going to make a copy. It's actually, because they're objects, they're pointing to the exact same thing. So I have dot here is a circle at 50-50 size 20, and I'm going to create another game object called ball that is now assigned to dot. And so they both will have the exact same object assigned to them. So if I do something to one, it's going to change the other one. So here I'm going to change dot of x to 70. Well, since both dot and ball are pointing to the same circle, the ball's x is also going to change to 70. So this is called passing by reference, or assigning a reference, which is literally the address is the same in memory of these two objects. They're both pointing to the same address where the values are stored. So dot and ball are essentially the same thing. Okay, if you want 3 different balls, you have to create 3 different objects. Ball 1, ball 2, ball 3. We're going to make the 3 balls, and now they wouldn't be the same. Now if you change the x of one, it's not going to affect the other ones. However, here I can now create another object in update that is going to tell me that it's going to see if the middle ball is clicked. So I create another object, and then I check to see if that object is equal to ball 2. So if the object clicked is the ball 2, then that is going to be the middle ball. If object clicked is ball 1, then that will be false. So it knows, CT object clicked, knows which object is being clicked. And you can compare the two objects, because up above they were equivalent. Well, here they might be equal, they might not be equal. Okay, here's another example. We have 3 balls. If any of the objects was clicked, then we're going to say you clicked an object. So here, what we're going to do is we're going to just see, so now you could have said if object equals ball 1, or object equals ball 2, or object equals ball 3, but that's very cumbersome. So what we can do instead is, if you did not click on an object, then the value of object is going to be null. So if you clicked somewhere on the screen where there wasn't an object, what this returns is something called null, which is a no object. It's an empty thing. So you can test to see if object is not equal to null, and then you can say that you clicked an object. If it is null, then you haven't clicked an object. So there's no point in telling them that they did. Finally, here we can have 3 balls, and then we have something called selected ball, and we can actually initialize that to null. So now we can test. If it's not null, we know something's happened. So we can assign selected ball to ball 1. We can print the x. Okay, we can set it back to null. We can check to see if it's null. No ball is selected. We can print it. So this is just showing that you can assign one object to another and then they are equivalent. You can take that object and assign it to null. You can assign it to a different object. You can do that and then you can test on what it's done. And then finally we have string comparisons, which we've already seen an example of as well. We can see if first name equals Dave, hey Dave. If last name equals first name, you have the same first name and last name. And I showed you already an example with equals. Okay, next I want to show you some the Pong examples. Here's Pong 8a. There's Pong 8 and Pong 8a. Okay, I'm going to pause this. Okay, let's look at this. And we already know it's a Pong, the Pong code. We're calling it Pong 8. We are setting the background. We're putting up the score. We have the paddles. But the part that's interesting is here. What we're going to do is we can actually see if a key is pressed. And there's CT key pressed, and the keys have names. So the up arrow key is called up, the down arrow key is called down, the W key is called W, the S key is called S. So notice these are strings. They have to be in double quotes even though it's a single letter. So if the key pressed is up, then we're going to move the Y of the paddle, right? The right paddle, because we're going to use up and down for the right paddle and we're going to use W and S for the left paddle. This is a two-player game. So we can change the paddle speed, or we change the Y by the paddle speed. So up here we've defined paddle speed to be 1. So what it's going to do is it's going to move, if we press up, it's going to subtract 1 from the Y, meaning it's going to move it up 1 pixel. If we press down, it's going to add 1 to the Y. So it's going to go down. So paddle speed doesn't really mean speed. It's not literally making it move. What it's doing is it's giving us an incremental amount of space to move, a number of pixels to move. And remember, this is going 60 times a second. So anytime you press up, the paddle will move by that amount. The same here with the W and S. You're now going to move the left paddle Y up and down. Okay? Then we have, so if you want to see that, I can resume and I can move the right paddle and the left paddle with these keys. So this is all I'm doing. I'm just moving the paddles around by pressing the up and down keys, or the W and S key. Now we want to check to see if we want to check what the ball's doing, and we want it to bounce off the top and bottom walls. Okay, so if the Y of the ball is less than the ball radius, which means we want the ball, like we don't want half the ball to show. We want the whole ball to bounce off the wall. And the Y is greater than the height minus the ball radius, then we're going to change the ball speed. So this way we don't have half the ball disappearing. We take into account the radius of the ball when it's hitting the top, and then we're going to make the speed change so that it's going in the opposite direction. And here the same with if it bounces off the paddles. If the ball hits a paddle, so we can test to see that it's one object hits another object, then we're going to change the speed of the ball to go in the opposite direction as well. So all we do is we say ball set Y speed to minus ball get Y speed. So we get the speed of the ball, we change it to the opposite value. If it was positive, it's going to be negative. If it's negative, it's going to be positive. So it changes direction. Okay, the same here with the X speed. We're going to, if it hits the paddles, this was if it hits the top or the bottom, if it hits the paddles, then it's going to change its X speed by getting the current X speed and making it go in the opposite direction. Okay, here, if the player scores, which means the ball hits the right side or the left side, then we know that the player has scored. So if the ball's X is greater than the width, then we know that the left person scores, and we increment their score, and we change the ball speed. So here the width is 100. So if it gets to 100, then it needs to bounce back, plus we know that the player on the right has scored. And conversely, if the ball gets to 0, then the player on the left has scored. We change their score, we change the text, we rewrite it, and we change the ball's speed to go in the opposite direction again. So let's look at this. So we resume. So you can see if it hits the wall, every time it hits the wall, the person scores. But you can also try to have it hit and then they don't score. Okay, so this is a very good example to look at. Make sure you understand it in order to do the next assignment. Make sure you understand what it is that's going on. There's also Pong 8. So Pong 8 is actually adding this part where you can serve the ball. So it says press space to serve. It starts with the ball in front of the left person's paddle, and it's going to alternate between them. And what this does is also, if I were to move the paddle, the ball is going to move with me. If I press space to serve, then I'm going to get a score, and then the paddle comes back. The ball comes back. So now that person scored. So now the ball is on the other side, and I can hit space bar, and it goes back and forth like this. So what does the code look like? We've added to the code. We still have all the beginning stuff. We still have the up and down keys being pressed. But now we're going to see if the ball is in play, we're going to do some things. Otherwise, we'll do something else. Okay, so let's first look. If the ball is in play, that is where we're going to use that code that we already had, basically. We're going to see if the ball bounces off the top wall. We're going to see if the ball hits the paddle. And if the ball is greater than the width, now we're going to increment the score, but we're also going to take the ball out of play. Okay, and now we're going to change the serve. So this starts here with the ball is in play is false, okay, and the right serve is false. So it's going to start with the left person is serving and the ball is not in play. So then if the ball goes off the screen to the left, then we know that the right person scores, ball in play is false, and now the right serve is true. So you need to, and then they have this serve message that either becomes visible or invisible. Okay, if the ball is not yet in play, that is where the ball is sitting here. We have this press space to serve. The ball is sitting in front of either the right or left paddle. If the right side is ready to serve, then right side is going to be true. So we're going to make sure that both the sides are ready to serve. Right side is ready to serve, okay, and the ball needs to be placed where the paddle is. If the ball isn't there yet, that's what we're doing here. Okay, so now we have to get it ready and place the ball. Same with the left side. We're going to place the ball in front of it. And then if the spacebar gets hit, one thing we're going to do is we're going to set ball in play to true so that the whole loop works again. We're going to make the serve go at some random angle. We're going to set the ball speed to some, these mathematical equations. If the right served, then we're going to set the speed going to the left, and otherwise it'll be going to the right. You only have to change the speed if it's going the other way. And then we're going to now make that serve message not visible anymore, and the ball is now in play. So this looks kind of complicated, but if you go through it carefully, I'm sure you'll be able to follow what is happening. You can look at each if statement and see that key pressed up, that changes the Y. Key pressed down, that changes the Y of each paddle. The ball is in play as opposed to the ball is not in play. What do? Well, if the ball is not in play, then depending on which one's serving, you set it up. Once the space bar gets hit, then the ball is now in play. Next time through, we're going to come here, the ball will be in play, and it will check to see if someone scored. Once someone scores, then the ball goes back out of play, and the next time through, we're ready to serve again. So hopefully looking at that and going through it makes it clear. If you have questions, please let me know. Okay, finally, I want to go through the programming assignment. So in this programming assignment, make sure that you set the syntax level to 8. Very important. You're going to write a program that uses if-else. You can do your own thing. You can make up a whole bunch of if-else statements, creating your own code if you want. Make sure that you use some Boolean functions, some Boolean variables, some compound expressions, have an if-else, an if-else-if, an else. You can try putting some nested if-elses in there. But there's also a suggestion here that you can start what you will be doing next week, which will be Project 1. Projects are worth more than programming assignments and are more involved, and you can actually get a start on that in this assignment. So what we're going to do is we're going to create a kind of Space Invaders game. So what you're going to have is an alien. There's one alien, and he's going to move back and forth on the screen. And you can make your alien just a circle or something. You are welcome when you do the project to make a picture, to find a picture that you can put in there. But for this assignment, just make these things shapes. It'll be easier. You won't have to worry about that extra step. And then in Project 1, if you want, you can. So if you make your alien a circle, a certain color, and he's going to start at the top left hand of the screen, and it's just going to move back and forth. Okay, so when the alien you're going to change the speed. It's going to move across. When it hits the right edge of the screen, it's going to go the other direction. So you're going to have to change your speed from positive to negative to get the X to move across. Then you're going to have a gun. You can make your gun a little rectangle at the bottom of the screen. So it's going to be at the bottom, and your left and right arrow keys are going to move the gun back and forth. So if you hit the right arrow key, it'll make the gun move over one to the right. Every time you hit the right arrow key, it moves over to the right. And make sure you can't go off the screen. That's another thing to test for. So that here, if your gun is on the right edge of the screen and you hit the right arrow, it stays there. And then if you hit the left arrow, it goes to the left, but make sure it can't go off the screen on the left side. Then you're going to have a bullet, and the space bar is going to fire the bullet straight up from the gun. So the bullet can also be a circle, maybe a little white circle or something. And and it's going to start wherever the gun is. So you have to look at the X and Y of the gun, and from there decide where you're going to hit the bullet. If somebody hits the space bar, the bullet is going to go straight up from there. There can only be one bullet on the screen at a time. So if there's a bullet on the screen and someone hits the space bar, you should not have another bullet. So these are some more things you need to test for. You need to test to see if there is a bullet on the screen. Once the bullet goes off the screen, you can delete the bullet, and I'll show you that note at the bottom. And then on the top right hand corner of the screen, you're going to have a score, so that later when if the bullet hits the alien, you'll increment the score. So you can think of the game as a number of behaviors, and what you should do is work on one behavior at a time. Just do the first one, get it working, then you can move on to the next one. So make an alien that starts near the upper left corner of the screen and starts moving back and forth. So you're going to set the object's X speed, and you'll have to get the object's X speed, because when it gets to the right edge, it has to switch. You'll have to know what the speed is in order to make it negative, okay, to go back and forth. Once you get that working, you'll have a gun that's at the bottom, and you'll want to move it back and forth with the right and left arrow keys, and those, when you have CT key pressed, you'll end up having the word right or left in there. So if you press the left one, then that will be true. If you press the right, you'll have to test on those strings, right and left. If there's not already a bullet in the air, then you're going to hit spacebar to fire one, and the bullet needs to start where the gun is. I already explained that. So you have to test to see if there's a bullet. If there is, you need to know where the gun is, and that's where you're going to start your bullet, and it's going to start moving up. So the Y speed is going to change. The Y of the bullet is going to be changing. So test to see if the bullet exists, and you'll know if it exists, because if it doesn't exist, you're going to set it to null. If the bullet goes off the screen at the top, it's deleted. So we're going to look at deleting it down at the bottom. And if the bullet hits the alien, the score increases by 1, and the bullet is deleted. So you can test to see if one object hits another by using object.hit. So you could say bullet.hit alien or alien.hit bullet. I would say bullet hits the alien. That would be true. Then you're going to increment the score that's up in the right hand corner, and you're going to delete the bullet. Okay, here are some general hints. Work on adding one behavior at a time, and after you add each behavior, test your game. Make sure that what you already had working is still working. You can also skip things and go back to them. Use printline or log in order to print out values, intermediate values, so you know what's going on. You can always do that as you're working, and then delete those prints at the end. Deleting an object, okay, so sometimes we might want to, it said delete the bullet, right? If the bullet goes off the screen, you need to delete it. If the bullet hits the alien, you need to delete it. So the bullet is a game object, and initially it's going to be set to null. So you can see if the variable is null, and if it is, you can create a bullet. And then once you want to get rid of the bullet, you say delete. There's a delete method. So it would be bullet.delete. And then you want to set bullet equal to null. So you delete it, but then you have to set it back to null so that you can then test on whether or not the value is null. So this is a very important hint here. Here are some other suggested functions to use and general advice. Basically, just build it slowly. Make sure you test each piece at a time. Use your if-else. You might if you're doing this project example, you're going to possibly need to do a few more things in order to get all of the requirements in. If you might need to add other features in order to experiment with more if-else's, because for this assignment you do have to do a little bit more for the requirements in order to get them all in. But if you can do all this, I will be very, very happy, and you'll have a big jump on the next assignment, which is going to be a project where we create this game. If you have questions, please email me. I'm here to answer your questions, and don't forget, I have my office student hour on Thursday from 4 to 5. So please take advantage of that as well. Have a great week, and I'll see you next time.